Hi guys, we are going to see today the concepts of Numpy. We are going to see what is Numpy, what is this Numpy library and other things. So before that, what I want to do is I want to just open my Jupyter notebook. So this is the Jupyter notebook and let us create a list. So I'm creating a list A with elements 10, comma 20, comma 30, comma 40. A. So this is A. And I'm creating another list B with the elements 50, comma 60, comma 70, comma 80. So this is the list. This is list B. Now what I want to do is my target is I want to add A plus B and I want to name it as city. C equal to A plus B. So what is this? This is list A. What is this? This is list B. Okay, so what is my target? My target is I want to do element by element operation. So what is that element by element operation? I want to
ಮತ್ತೆ ಅದೇ ಏನ್ರು ಆಮೇಲೆ ಸರಿ ಅಡುಗದ ಕ್ವಶನ್ಸ್ ವೀಡಿಯೋಸ್ ಪೈన ಅಂತೆ.
I'm getting some disturbance. So what is my target? I want to do element by element operation. That is what my target is. So I want to add this 10 to 50, 20 to 60, 30 to 70, and 40 to 80, and I want to get resultant in the form of C. Let us try to add and see. Okay, so C, right? See. What happened here? We got the result. So we have tried to add this A plus B, but the result it is like this. What it is doing, this plus over here, it is acting as a concatenating operator and we are getting this 10, 20, 30, 50, 60, 70, 80 like. But it is not doing this addition. So not only addition guys, using the list and other data sets, we cannot do addition or subtraction or anything. So if you want to do any mathematical operations, how to do? So what is the solution for that? The solution is nothing but this NumPy. Okay, so NumPy is a library. So if you see what is the definition of NumPy, NumPy is an extension to Python programming language, adding support to multiple dimensional. So NumPy deals with the arrays and matrices. And what type of dimensional? Multiple dimensional. So you have one dimensional, you can have two dimensional, and sometimes you can have more than two dimensional. Okay. So what is this NumPy? NumPy is extension to Python programming language, adding support for multiple large and multiple dimensional arrays and matrices. So why we use this NumPy? So NumPy, what it will do is it is a fundamental library needed for scientific computing with Python. So what you can do various operations like you can do a n-dimensional array, you can do array slicing, you can do array reshaping, and you can do certain mathematical routines like linear algebra transformation, Fourier transformation, random number capabilities, and other things. Yes, so this is all we can do. So thing is what you need to remember is first point. What is the first point you need to remember? This NumPy, it deals with the arrays and matrices. Okay. So you may ask what is the difference between arrays and matrices? So both are same, but thing is an array can exist in one dimensional, an array can exist in two dimensional, and an array can exist in three dimensional also. But matrix always exists in two dimensional. That is the difference. So what we can do using these arrays and matrices, you can do linear algebraical functions, Fourier transformation, and random number capabilities. So mainly, most of the things we will be working with arrays. So arrays are very important. Okay, and arrays can be one dimensional, two dimensional, and three dimensional. Fine. So if you see If you see what is main numpy's main object is ND array, homogeneous multi-dimensional array. So another point what you need to remember is an array is a homogeneous one. So it consists of a homogeneous data. For example, I have here an array. So it has data 1, 2, 3, 4. I have another array. So this is one dimensional one. So it has A, B, C. I have another array. It has 1, A, 2. But if you see here, it consists of numerical data. Here it consists of textual data. Here combination of numerical data and textual data. But array, you cannot have a combination like this. Either you can have a numeric data or else you can have textual data, but you cannot have the combination. So that is the reason it is a homogeneous multi-dimensional array. So it can be a two-dimensional also. So where it consists of rows and columns. Okay. So what can be done using these arrays? You can suppose, for example, I have an array like this. Consider I have an array like this. So what is this? This is a two-dimensional one. I can do array slicing. So if I want, I can get only this part. If I want, I can get only this column. Okay, so if I want, I can get only this row. Like that. We can do array slicing, we can do indexing, and again, this arrays will have indexing, and indexing will starts with zero. So when it is, if it is a two-dimensional one, so its row index is 0, 1, 2, 3, and column index is also 0, 1, 2. Okay. If it is one dimensional, it don't have row and column index. It will just have index like 0, 1, 2. Okay. So we can get a particular element outside also. You can slice it and you can get some information from that one. And do remember, so mostly this NumPy arrays are very important because we convert a data into a NumPy array. Why it is needed to convert a list into a NumPy array or anything into a NumPy array is the main reason is in order to do mathematical calculation. So when you convert this anything into NumPy array only, we can do mathematical calculations. And next thing, machine learning models and deep learning models. What we do, we convert the data into a two-dimensional array or a one-dimensional array so that to perform certain mathematical operations. You know, like machine learning, deep learning models and all. So what is the base for them? Mathematics is the basics for them. Okay, so they are built on the base of mathematics. So to do this mathematical calculations and all, you definitely need to convert a list into an array and you need to do mathematical calculations. Okay, so that is handy array. So now NumPy, and now let us see how to work with this NumPy array and how to deal some things with this now. Okay, so what I'm doing, let me open my Jupyter notebook and let us programmatically work with this NumPy array. Then speaking theoretically, if you work practically, then you can understand what is this NumPy and other things. Okay. So so here I have a list, underscore list with elements 1, 2, 3, 4, 5. So listen carefully how we are making. So here I have a list, the name underscore list. It has elements 1, 2, 3, 4, 5. So run it underscore list. So this is list. So already we had seen that we cannot do some operations like mathematical operations using this list. But here I have a list. So what we have to do, so this list consists of elements 1, 2, 3, 4, 5. So now let us convert this list into a NumPy array. So what is the first step you need to do? You need to convert this list into a NumPy array. So how to convert that list into a NumPy array? So from here, converting into a NumPy array. So ARR 1D, so 1D means one dimension. Okay. NP dot array of underscore list. If you see here, what I'm doing, np dot array. So I want to convert this underscore list into a numpy array. This underscore list. And I am naming this complete array from which I am converting the list into array and naming it as underscore ARR. So what is this NP? I will tell you. So now let us run this code. See what it is saying. Name numpy is not defined. So Python does not know what is this NP is. Okay, so for that, what you have to do is you have to import certain libraries. Yes. So mandatory libraries generally from now onwards, what we need to do is in order to do some work or in order to do some coding thing or in order to build a model. So basically we need to import certain libraries. Okay. So among them, first what you have to import something called as OS. Import OS. Next, import NumPy as LKP. Okay. So what is the meaning? We are importing OS. In that OS, we have these libraries at all. So NumPy, Pandas, and other things. Okay. So you are importing NumPy library as NP. What is this NP? It is a alias name. Okay. So I am importing NumPy with the alias name of NP. Generally, all the programmers, what they do, they import NumPy with the alias name of NP. That is customized thing, but it is not mandatory, guys. You can import NumPy with any of the alias name. For example, I want to import NumPy with AB as AB. Okay, so what I'm doing, I'm changing here as AB. Okay, underscore array. Try to run that one. See, it got it. So what we have done, we have taken this list. What is the list? This is the list. And what we had done, we had converted into an array and we had named it as underscore ARR1B. So if you see underscore ARR1B, so this is it. So if you see here, before that array is mentioned and that will be within parenthesis like this. Fine. But I just told you, you can import NumPy with any of the alias name, but generally the custom is importing NumPy with the alias name of it. So I will use NP. Here again, I will use NP. So now try to run that one. Okay. So we have run that. So we had converted this underscore list into an array. Okay, and I'm naming it as underscore ARR. Now what I will do is I am printing this underscore. Okay, so before printing, if you ask type of underscore list. So this is underscore list. So if you ask type of underscore list, what it is saying? It is saying it is a list. Suppose if you ask for type of underscore ARR1D, try to run that one. So it is saying it is numpy.ndl. Okay. So it belongs to this underscore ARR1D, it belongs to numpy.ndl. So what is this ND array? Means n dimensional. So it can be one dimensional, it can be two dimensional, or else it can be three dimensional. Okay, so three dimensional data is called as panel data. Do remember, we will discuss about panel data in the coming up sessions. As if now, just think only about one dimensional and two dimensional concepts. Okay, so that is what the thing is. Now come here. So my underscore list one equal to elements 1, 2, 3, 4, 5. My underscore list 2, it has elements 2, 3, 4, 5, 6. My underscore list 3, it has elements 3, 4, 5, 6, 7. So if you observe here we have three lists, guys. So one is with the name my underscore list one is with the name my underscore list 2, and one with the name my underscore list 3. So let us run that one. Now what I'm doing, I'm taking these three lists and converting them into an array. So what I'm doing, I'm taking these three lists and converting into array. So for that, what I'm using here this one. So what is this? What is this you are seeing? What is the highlighted text? What is that? Can anyone tell what is this is? What is this? My underscore list one, comma, my underscore list two, comma, my underscore list three.
Making three lists into single list, sir.
Pardon?
Making three lists into single list.
Making three lists into single list. So what it is called as?
Making list to array.
Nested list, sir.
Very good. So it is nested list. So if you see here, nested list means if a list consists of another list within it, it is called as a nesting list. If you see here, we have a list and in that you have multiple lists. So what I'm doing, I'm taking these three lists and what I'm doing, I'm converting into an array and I'm naming it as AR, right? So ARR. Right. So we got an array. Okay. So this is a two-dimensional array. This is a one-dimensional array. So one difference you can observe, see here we have one square bracket and if you see here we have two square brackets. Suppose if I ask for type of AR, so it says that it is numpy.ndr. So even if it is a one-dimensional or even it is a two-dimensional, always when you ask for an array, it says that it is a numpy.nd array, right? So here we had made a two-dimensional array. So how we have made this two-dimensional array? We have taken three different lists and we had made it two-dimensional array. Okay, so let us explore more. So ARR dot shape. ARR dot shape. Correct. See 3 comma 5. So what is this 3 comma 5? So it is specifically saying that if you observe here, it has 3 rows and 5 columns. So 3 comma 5 means 3 rows and 5 columns. Dot shape will give you the shape case. So these are some things which you remember. So ARR dot reshape. So I want to reshape this one. So if you see here, go to Numpy. So what you can do, you can do reshaping, array reshaping method. So we are doing the reshaping and slicing and other things. So come here, ARR3 dot reshape. So actually the original array is 3 rows and 5 columns. And what I'm doing, I'm trying to make it into 5 rows and 3 columns. See, we made it into 5 rows and 3 columns. Not only 5 rows and 3 columns, we can further do the changes also. For example, here dot reshape 1 comma 15. I want to reshape it to 1 comma, correct? Yes. So we had reshaped into 1 comma 15. I can further reshape also. Suppose I want to reshape into 4 comma 5. So 4 rows, 5 columns. Run it. See, it is throwing an error. What is the reason why it is throwing an error? Can anyone explain?
There is not elements are
It's not
not there,
possible
sir.
to do that.
Pardon?
The elements are not sufficient for this.
Elements are not sufficient. That's very good. So if you see here, how many elements are there? 3 rows and 5 columns means 3 into 5, 12 elements are there. So here also 3 into 5, 15 elements are there. Here also 5 comma 3 means 15 elements. But here 4 comma 5, that means 20 elements. So 15 elements we are trying to make into 20 elements. That is not possible. That is the reason it is throwing an error. But the same thing can be achieved in our language. We already have seen if you remember. Okay. So that is what you need to remember. Next. ARR underscore 1D. So let us check what is ARR underscore 1D, right? See, this is ARR underscore 1D. So underscore ARR 1D of 3. Of 3. So what is this? This is index. So what we can do from an array using index, you can grab a particular element. So this is 0 index, this is 1, 2, 3, 4. So what I want to get, I want to get three index items. So what is the three index item? You'll get that 4 outside. Okay. So we can get a particular item as well as we can do slicing also. Underscore ARR 1D, 1 column 3. 1 column 3. So 1 column 3 from first element to third element. Okay, so 3, what you have to do, right hand side, you have to do a -1. So for disciplinary sake, I'm explaining this again. Please listen carefully. Okay, so always, so what is the index? 0, 1, 2, 3, 4. So this is left hand side and this is right hand side. Left hand side is inclusive. So that means give me from one index to the right hand side, you have to do a -1, 3 minus 1, that is equal to 2. So one index to two index. So one index is this one and two index is 3. So you will get the 2, 3 outside. Rather than that one. So we got the 2, 3 outside. So if you slice an array, obviously the output also you will get an array. So if you slice a mango, you will get a mango, right? So similarly, when you slice an array, the output will be an array. Next. Okay, list underscore 2. Let us see underscore list. Right. So this is list. If you see, this list consists of elements 1, 2, 3, 4, 5. So now what I'm doing, I'm adding a 2 to this list. So for each and every element, I want to add a 2. Let us run that one. It will throw an error. You can't do such type of additions. But we had created one thing. What is that? Underscore ARR1D. Let us run underscore ARR1D. So it consists of elements 1, 2, 3, 4, 5. Now what I'm doing, I'm adding a 2 to ARR underscore 1D. Okay, so what I'm doing, I'm trying to add this 2 to each and every element. This 1, 2, 3, 4, 5. Let us run that one. See. Now the resultant is 3, 4, 5, 6, 7. Okay, so the main thing is using this arrays and matrices, what you can do arithmetical operations. That is what you need to remember. So not only addition, guys, you can do multiplication also. So print underscore ARR1D into 4. Okay. So not only multiplication, you can do division. So each and every element I want to divide with 2. Right. Okay. 0.5, 1, 1.5 and print ARR1D. Okay. Double times divided by 2. See, we got the result like this. Okay. So there is, if you observe, there is a difference between this and also. Here we had used one backward slash symbol, but here we are using two backward slash symbols. So when you do two backward slash symbols, what it will do is, it will be getting truncated. So originally 1 divided by 2, we have a result of 0.5. So 0.5 is truncated to 0, 1 is truncated to 1, 1.5 is truncated to 1, 2 is to 2.5 is truncated to 2. Okay, so this double time. Okay, so what it will do, double backward slashes, it will truncate the result. Fine. Next, NP of zeros. NP dot zeros 5. So what is this? What we get? See, we will get an array of 5 zeros. Suppose if I say NP of zeros 2 comma 3, what I will get? Sorry, I will change that one. So let us check this one. We'll go slowly about it. So MPs of zeros of 5, what we'll get? You will get 5 zeros. Suppose if I say NP dot ones, NP dot ones. So what you will get? You will get 5 ones. Okay. Suppose if I say NP dot twos of 5. So what we have to get, guys? NP dot twos of 5.
Or two, sir.
5 twos.
5 twos. Okay, let us run that one. See here. So there is no module or no attribute with twos. Only this facility is for ones and zeros. Yes, ones and zeros. Why? Because you have already worked with diabetes data set. So when the diabetes data set, if a patient is suffering with diabetes, we used one. If a patient is not suffering with diabetes, zero. So this ones and zeros will play a lot of role in the machine learning models, deep learning models, and all. So this provision is for zeros and ones only, not for twos and other things. And not only a one-dimensional case, you can get two-dimensional zeros as well as two-dimensional ones also. So how to get two-dimensional zeros and two-dimensional ones? So suppose here we have np dot ones. What I'm doing is I'm changing it to 3 comma 3. So 3 rows of ones and 3 columns of ones, right? You got 3 rows of ones and 3 columns of ones. Not only ones, zeros also. Suppose if I say 5 comma 5, that means 5 rows of 1, 5 columns of 1. So 5 rows of zeros, 5 columns of. So you can get that, right? And here. So I have underscore list. So underscore list, it consists of elements 1, 2, 3, 4, 5, 6, 7, 8, 9. Underscore LST, right? So it consists of 1, 2. Now let us convert this underscore list into an array. So I'm converting that list into an array, np.array. So what I want to convert this list. So np.array underscore list, and I'm naming it as underscore ARR. Okay, so now let us check underscore ARR on it. Save. So I have made this into an array. Now what shall we do is underscore. So underscore ARR 5 column, what we are going to get?
6, 7, 8, 9, sir.
6, 7, 8, 9. Okay, let us see, run it. Yes, we got 6, 7, 8, 9. So how we got that 6, 7, 8, 9? The 6, 7, 8, 9. So this is index 0, 1, 2, 3, 4, 5, 6, 7, 8. So 5 columns. So here left hand side 5 is mentioned and in right hand side nothing is mentioned. When nothing is mentioned, what is the meaning? Give me till end, from fifth index to till end. So this is from fifth index to till end, that is ninth index. Okay. So today only I will explain these things, guys. Later on, I will not explain this type of basic topics. Do remember. So you need to go through the recordings. Every recording is there. You can go through the previous recordings. Fine. Next. Now what I'm doing is ARR 5 colon equal to 100. So now if I run underscore ARR, what is the result going to be? What would be a underscore ARR?
Sir, it will change the values from fifth index to eighth index to 100, sir. All the values.
All the values, right? So if you see here from sixth index to 6, 7, 8, 9 elements, what it will do, they will become hundreds, all hundreds. That is what we are doing. Is so we had done already when we worked in R. I guess you have forgotten this thing. Okay. But please don't forget. Next. Val equal to 300. Val equal to 3. So what is val? Val is 3. So now underscore ARR less than val. Underscore ARR 3 less than val. So value, if you see value is 3 here. So I want to get those numbers where the I want to get those numbers of the array where they are less than. Okay. Correct. So if you observe here what has happened, see what is the condition? The condition is less than val. What is val? Val is 3. If you see 1, yes, 1 is less than 3. We got true. 2, yes, 2 is less than 3. True. 3 is not less than 2. 3 is equal to 3. So that is the reason we got this. Okay. Now, I don't want to get this true, false, false, false and all. So I want to get those particular numbers which are less than value, that is 3. Then what is the piece of code you have to use? You have to use this piece of code. Underscore ARR of the condition. What is the condition? A underscore ARR less than val. Now check it. See, we'll get those values which are less than the value. Okay, so that is what to get. Next, np dot linspace 1 comma 10 comma 50. Okay, what is this? What is this linspace? So linspace, do remember these words, guys, these terminologies, these are very important.